Good afternoon, grade 12s. Welcome to the telematics broadcast of today's lesson. And today's lesson will be on measurement. My name is Mrs. van Graan and I'm a teacher at CBC St. John's in Parklands. All right, so let's start with measurement, and let's see. Measurement is not just to work out the length and the breadth of objects. So let's have a look at what can you expect in a measurement question. All right, so if we then, if you look, I hope you have your notes with you that was provided, but if you don't have, so let's have a look at what I have in front of me. Okay, so what does measurement consist out of? So first of all, I just want to go through the points here. Measurement is length. So what is length? Length is the distance around the outside of a shape. So length and perimeter. Length is and perimeter is more or less the same thing. Length will be the distance between 2 points, and perimeter will be the distance around the outside of a shape. Then area, what is area then? Area is the amount of space inside the boundary of a flat 2D shape. All right, so area is like length and breadth. Volume is then the amount of solids or liquids that an object can take, or if you can hold. Surface area is the sum of all the areas of all the surfaces of a specific 3D shape. Weight will be something like your BMI, your body mass index. That's also part of measurement. Temperature is when you work between degrees Celsius and degrees Fahrenheit, when you do conversions with a formula there. And time can be timetables, where you get timetables and you need to work out, or you need to work out how long it took you from one place to another, where we use our time formula. So all of these bullets here you can expect in a measurement question. All right, so let's start with any further ado. Let's start today's lesson with the questions. Okay, so the first question that I have for you, it says a diagram of the cricket pitch is shown below. Study the diagram and answer the questions that follow. All right, so sometimes people will say that they have no idea what cricket is about, but you don't have to know anything about cricket. They provide you with all the necessary measurements of the cricket pitch. So first of all, they show you the length of the pitch. Then they show you the stumps where the batsmen stand. They show you that is 2.64 meters. They show you that the length, or the breadth if you want to, is 3.66 meters. And then the two batsmen need to run. They need a space to run. They call it a running place from one stump to another stump. So that is the length of the running place. That is the length of the whole pitch. So the first question that they ask is, explain the term perimeter. Grade 12s, what is very important is that you need to make a little list of all the definitions that you need to know, because it is important that definitions, it's like in business studies, you study a definition and you need to then give the correct definition. Not definition in your own words, a definition as per your textbook. So explain the term perimeter. So perimeter means, perimeter is the total distance around the outside of the shape. So if this is the shape, then it will be right around the outside, the edges of a specific shape. Then it is perimeter. So you start at a certain point and you walk the distance, you walk it again, you walk the distance, and then you come to the point where you started. So you went around the object or the shape. So perimeter is the total distance around the outside of the given shape. So let's move along to question 1.1.2. 1.1.2 says, calculate the perimeter of the area where the players run during cricket overs. All right, so where they run, running place. So it will be 17.68. So remember, we're doing the perimeter where they run. So we're going to do the 17.68 and another 17.68, 3.66 and 3.66. Then we did the perimeter of the running where they run during cricket overs. So 1.1.2, you will say perimeter equals 17.68 times 2 or plus 17.68, however you want to do that, and then 3.66 times 2 or plus another 3.66. Let me show you. You can either do it like this way here, or you can say plus 17.68 and 3.66 plus another 3.66, and then the perimeter around the running place where they're going to run will be 42.68 meters. The next question is 1.1.3. Calculate the area in meters squared of the cricket pitch. All right, so now the cricket pitch is the bigger part. The pitch is 22.56 meters, 56 meters in length and 3.66 meters in breadth or width. So now we're going to work out area. So we write down our formula. This is a rectangle. So it's length times breadth. So the length is 22.56 meters multiplied by 3.66 meters. Both of them, the measurements are in the same unit. We multiply them and we get 82.57 meters squared. Why is the answer for perimeter only in meters? Because it's one thing that we are measuring, which is distance around an object. That's why it's meters. Area, why is it meters squared? Because we are working with 2 dimensions. We are multiplying length times breadth. We want the area where they are running. That's why it is in meters squared. Also, grade 12s, as you can see, at each question, a formula was provided. So, with the question, this is how you will get questions in paper 1s, all right, where the formula is given at the specific question and you actually just need to do the substitution. All right, so then we are going to move along to the next question. And the next question is the Hermanus High School Hiking Club. I just want to bring it down. There we go. We can see it now. So the Hermanus High School Hiking Club decided to go and do the Fish River Canyon hiking trail in Namibia. On their route, they first visited the Agrabis waterfall near Uppington. So one of the girls, Talia, packed a cooler bag for the road. She puts 2 6-pack cans in the cooler bag. 2 6-packs can fit exactly on top of each other in the cooler bag. A can has a diameter of 6 centimeters and a height of 8.84 centimeters. So let's have a look at what they gave us in this specific question. 1 cool drink can measurement was given to you. Please remember grade 12's pi, we use 3.142. then the cooler bag, they give us a very important conversion, and they give us the volume, two volume formulas. One says pi radius squared times height, and one length times breadth times height. So in this question, they don't give it at the questions that they ask here. They give it with all the information at the top. So then you must know that this volume is for a cylinder, and this volume is for a rectangular prism. So a cylinder in this question will be the can, and a rectangular prism in this question will be the cooler box. So let's go and have a look at what it is that they ask. So the first question that they ask is, calculate the volume of 1 can of cool drink rounded to the nearest whole number. Now that is important because there's two things in this question that you need to think about. First of all, calculate the volume, and then the second part, which sometimes we forget, round to the nearest whole number. So let's go and start and do the first one. So 2.1.1. So calculate the volume of 1 can of cool drink. We know the can is a cylinder, and we are going to use that formula. So we are going to say volume is pi radius squared times the height of the cylinder. So then, what is volume? What is pi radius square? Pi radius square is the area of the base on which the cylinder is standing, and a cylinder stands on a circle. So that's why it is pi radius square. So if we have the cylinder here, a cylinder stands on a circle. So the volume of any prism is area of the base times the height of the cylinder. So pi radius squared times height. Pi is 3.142 times, and then they said the diameter of the cylinder is 6. Diameter is 6 centimeters. So if we divide it by 2, we get 3 centimeters, which will then be the radius. So it is 3.142 times 3 squared, the formula, times the height of the cylinder, 8.84 centimeters, 8.84. The 3 is in centimeters, the height is in centimeters. Both of the measurements in this formula, they are in centimeters. You can go ahead and do the calculation. No conversion needed. So then, if you are going to do the multiplication with your calculator, 3.142 times 3 squared times 8.84, the answer is 249.97752 centimeters cubed. Why are we using centimeters cubed? It's volume, it's 3 dimensions, that's why cube. All right, so the question said, calculate the volume around to the nearest whole number. That is the second part of the question that we need to do. So we are rounding it to the nearest whole number. So if we do this rounding and we start to do the rounding nearest whole number, look at the first decimal, it's a 9. It will have an influence on that 9, and the 9 will have an influence on the 4. So therefore, it's 250 centimeters cubed. I'm going to do it again. So to the nearest whole number, you're going to look at the first decimal. It's a 9. The 9 is going to have an influence on this 9. It's going to change it to a 0. It's going to carry over, and that is going to become a 5. Therefore, 250 centimeters cubed. That was question 2.1.1. Then 2.1.2, write down the capacity of 1 can of cool drink in milliliters. 2.1.2. I have 250 centimeters cubed. That's what I have. I have this amazing conversion which says 1 centimeter cube equals 1 milliliter. So therefore, if they want me to convert this to milliliters, so 1 centimeter cube equals 1 milliliter, so 250 centimeters cube will therefore also be 250 milliliters. Question 2.1.3. Calculate the height of the cooler bag rounded to the nearest whole number. Again, two things. We are going to work out the height of the cooler bag, and then it says rounded to the nearest whole number. So let's do the first thing first. 2.1.3. Calculate the height of the cooler bag. I want to take you back to the second sentence. She puts 2 6-pack cans in the cooler bag. 2 6-pack cans fit exactly on top of one another in the cooler bag. So if she can put 2 of these 6-packs on top of one another, it will give me the height of the cooler bag. One can is 8.84. So if I'm going to go and I'm going to work out the height of the cooler bag, I'm just going to take the height of one can and I'm going to multiply it by 2. Why? Because she's stacking 2 6-packs on top of one another. And then it gives me 17.68 centimeters. Now I want to go back to the second part of this question where it says round it to the nearest whole number. So if I take 17.68 centimeters and I need to round it to the nearest whole number, it is 18 centimeters. Then the last question regarding the cooler bag, 2.1.4. It says calculate the volume of the cooler bag if the breadth of the bag is 12 centimeters and the length is 18. Okay, so they are telling us that the volume, we need to calculate the volume of the cooler bag. So they already gave me that formula. There it is. Volume is length times breadth times height because it's a rectangular prism. And they gave me the breadth of the bag and the length of the bag. So they say the length of the bag is 18. So they tell me that is 18. They tell me that that is 12. And I already worked out the height of the bag in the previous question, which is also 18. So I have all the measurements. So the length is 18, the breadth is 12, and the height of the cooler bag is 18. And therefore, if I say 18 times 12 times 18, it is 3,888 centimeters cubed. Why could I multiply them with one with the other? Because it was 18 centimeters, 12 centimeters, 18 centimeters. All the measurements were the same in the sum. Therefore, I could do the multiplication. No need to do any conversions. All right, so that was the end of 2.1.4. Then we're going to move along to the next question, number 2.2 on your notes. They say Cornel is very tall and made a tent with specific measurements. So Cornel wants to go camping. They give you lots of bullets and information. The length is 2.45, so they give it to you in bullet form, but they also give it to you on the diagram. The breadth is 1.75. The slant height, that's the slant height, that is the slant height, is 1.37 meters. And the perpendicular height, that is 1.5 meters. All right, so you have your drawing of the tent, and now we are going to go and answer the questions regarding Cornel's tent. So the first question that they ask me in connection with this question, it says, calculate the amount of material that is needed to make the tent. The ground cloth or ground sheet is attached to the structure of the tent. In other words, you have the tent and then you have a ground sheet as well. So when this is a triangular prism, and in a triangular prism, you have 5 surfaces. So let's count the surfaces. So we have a triangle here, and then we have exactly the same on the other end. So it's 1, 2 surfaces. Then I have a rectangle on this side, but I also have a rectangle on the other side. And then I have the ground sheet or cloth, which is also a rectangle. So I have 1, 2 triangles, 1, 2 rectangles, and then I also have the ground sheet. So I have 5 surfaces in a triangular prism. So the question, let's go back. They say we need to work out, calculate the material that is needed to make the tent. In other words, we need to work out the total surface area of all 5 surfaces. So a formula was provided to work out the surface area. So it says 2 times, I'm just going to rewrite it here. So 2.1, it says 2 times the length times the slant height. So the length is 2.45. The length is 2.45 meters times the slant height, 1.737 meters, plus the length. So we are going to plus the length again, 2.45, multiplied with the breadth of the tent, which is 1.75. And then we are going to say, I'll put the 2 at, or you can put the 2 in front. 2 times the base is 1.75, multiply with the perpendicular height, which is 1.5. This was the formula that's been given to you. So if you then go and you work out, multiply the bracket and multiply it with 2, 85113. You multiply that bracket, you get 4.2875 plus 2.625. We times it by 2. Then the answer, I just need to quickly check myself if I already did 1.75 times 1.5 times 2. It is, this answer is 5.25. Then I go and I take this one, that one, and that one, and I add them together, and I get 15.4238 centimeters squared, and I'm going to round it to 2 decimal places, 42 centimeters squared. Why centimeters squared? Because it is total surface area. All of these, it's meters. Sorry, grade 12. I realized the measurements was in meters. There was no conversions needed because everything was in meters. So it is meters squared. So we worked out the cloth that Cornel was going to buy to make the tent. That's the total amount of meters squared that he needs to buy. Then we continue to the next question. So this is a question on temperature, which is also measurement. It's 2.2.2. The daily temperature of Namibia is shown in Fahrenheit. If the minimum temperature on Sunday will be 47 degrees Fahrenheit, convert the temperature to degrees Celsius. All right, and then they give you two formulas. They give you the degree Fahrenheit formula, or they give you degree Celsius formula. So which one do you use? So you want to convert from the Fahrenheit to Celsius. So we are going to then use the Celsius formula. Degrees Celsius, what does the formula say? The formula says I need to take the degrees Fahrenheit that I have minus 32 divided by 1.8. So I'm going to substitute into the formula the 47 degrees Fahrenheit that I have. Minus 32 divided by 1.8. So when we do the order of operations, bracket comes first. So you first need to say 47 minus 32. So 47 minus 32 gives you 15. And then you are going to divide that by 1.8. And that gives you 8.3 degrees Celsius. And then we are going to move along to question 2.2.3. And this is a question about time, which is also part of measurement. So let's go and have a look at this question. In this question, they say the distance from Hermanus to Upington is 979 kilometers. The hikers leave Hermanus at 5 o'clock. Now that is 5 o'clock in the morning. They travel at an average speed of 110 kilometers per hour. They stop twice for half an hour each time to fill the petrol tank. At Springbok, they spend an hour and 6 minutes on lunch. Determine the time they will reach the destination in Upington. And then they say you may use the formula distance equals speed times time. Now, before we get to which formula to use, this is the correct formula for distance. Distance is speed times time. It's not necessary to say that we are going to use this specific formula. It depends on what they ask. So let's have a look. There's lots of information in this question, grade 12s, so we need to start sorting them out. So first of all, write it down. Write down what it is so that you can remember. You can't go back to the question every single time and read and read and read. So I suggest that you write down important information. For me, it's important to know that from Hermanus to Upington, it is 979 kilometers. That is something that's important. Then it's also important that I know when we are leaving. So we are leaving at 5 o'clock in the morning. We are leaving Hermanus at 5 o'clock in the morning. We are traveling at a speed of 110 kilometers per hour. Then we are stopping twice. All right, so we are 30 minutes times 2. We are stopping to fill the petrol tank, all right, which is 1 hour. And then lunch. Lunch will be 1 hour and 6 minutes. They are all very important information. And then they say, determine the time that they will reach the destination. So we are leaving Hermanus. We have this amount of kilometers to travel. We start our journey at 5 o'clock. We travel at 110 kilometers an hour. We fill the petrol tank twice on our journey. It takes us an hour, and we stop for lunch for an hour and 6 minutes. When are we going to arrive in Upington? If we take all of this into consideration. So, very important, my triangle. What is it that they want? We want time. Determine the time they will reach the destination. So we have time. We have the time that we stopped for petrol to fill up the tank. We have the time that we stopped to have lunch. But we don't have the time, how long it took our journey for 979 kilometers an hour. So we are going to work out the time for the journey. So the time for the journey is distance divided by speed. So it is distance divided by speed. What is the distance? I have the distance. The distance is 979 kilometers. What is the speed? I have the speed. The speed is 110 kilometers per hour. If I take my calculator and I say 979 divided by 110, I get an answer of 8.9. So if I get the answer of 8.9, I have kilometers and I have kilometers per hour. So this answer can only be 8.9 hours. So what must I do? They want to know when will we be arriving in Upington. So I leave at 5 o'clock. I need to add the 8.9 hours to the 5 o'clock. I need to add the 1 hour to the 5 o'clock, and I need to add the 1 hour 6 minutes for lunch to the 5 o'clock. And then I need to get the time when we are going to arrive in Upington. What I first need to do is I need to take the 8.9 hours and get how many hours and minutes. So the 8 hours can never change. It's already 8 hours. It is not 90 minutes. Otherwise, this will not be 8 hours. So the 8, what's in front of the comma, cannot change. I need to go and work out what is the 0.9 hours. This is 0.9 of a full hour. So I am going to, remember, the 8 cannot change. 0.9 times 60. It is 54 minutes. This is then 8 hours and 54 minutes. 8 hours and 54 minutes it took me to do the distance, to drive the time of 979 kilometers. Then I add another hour. That's that hour which I filled my tanks. And I add the 1 hour and 6 minutes for lunch. Fill up petrol, lunch. This is the journey. So, in total, when I add everything up, 8 hours plus another 1 hour is 9, plus another 1 hour is 10. 54 minutes plus 6 minutes is another hour. So in total, this is 11 hours it took me for the whole journey. So now I'm taking the 11 hours and I take the 5 o'clock in the morning. 5 o'clock in the morning, I plus the duration of the 11 hours that it took me to do everything. And if I add it together, I will arrive at Upington at 1600 hours. Of course, this is 4 o'clock in the afternoon. So that was question 2.2.3. So then we are going to move along to question 3.1. So question 3.1 African Concrete Blocks is a company that manufactures squared concrete blocks. Very important information that they provide square concrete blocks. So all of these blocks below are squares. The diagram below shows the 6 steel molds that they use to make the square concrete blocks. So 50 centimeters, so if it is a square, this will be 50, that will be 50 centimeters. It's a mold to make the square concrete blocks. And then they tell us the depth of the block is 80 millimeters. So I have a problem, which I realized from the beginning, and that I have 50 centimeters and I have 80 millimeters. So I can't work with them. I need some other guidance or a hint or assistance in my question that will tell me which one must I convert. So then we are going to move along to the questions about these concrete blocks. So the first question that they ask about the blocks is explain the meaning of volume. All right, so that is a definition, and a definition you must study. So what is the definition of volume? Volume is the amount of solids or liquids an object can hold or take, whatever can go into the block. All right, then the next question, 3.1.2, calculate in meters cubed. Now remember I said they must give us some other hint, and there it is. They gave you the hint. The hint is convert everything to meters. So the answer, they want the answer in meters cubed, the volume of one concrete block. And then they say the volume is side times height. So there we have it. Conversions must be done to meters. So if I take 80 millimeters and I want to convert 80 millimeters, so I'm sure you know King Henry died miserable death called measles. It's the easiest way to convert. So where are we? If you have millimeters is there's centimeters, and there's meters. So I am currently there with 80 millimeters. I want to go to meters, so I divide by 10, I divide by 10, and I divide by 10. So 80 millimeters is 0.08 meters. 50 centimeters will be here. And then I need to go to meters, divide by 10, divide by 10. So 50 centimeters will be 0.5 meters. Very important to know your conversions. So we are going to keep that there. So we are going to do 3.1.2. That's the volume of one of the concrete blocks. So they gave it to us. They said it's side times height, or the depth. So this side, I'm going to show you again what we have. We had 50 centimeters times 50 centimeters times 80 millimeters. As it is, we cannot work with this in one question. The units must be the same. So what we need to do is look at the hint. The hint they gave was that everything had to be converted to meters. So then we are going to do that. I showed you we did the conversion here. So it is 0.5 meters times 0.5 meters times 0.08 meters. Now everything is in meters, and we can continue with doing the multiplication. So if we do this, we get 0.02 meters cubed. Why cube? Because it is volume. So that is the volume of one concrete block. Then they give you at 3.2, they say Thabiso wants to renovate the walkway in his garden. He wants to replace the grass on the walkway with concrete blocks and pebbles. So he wants to put the blocks there, and then he wants to put pebbles between them. The dimension of the walkway, so the walkway is 4.05 meters by 1.4 meters. That's been given to you. They again give you dimension of one block. One block is 50 centimeters by 50 centimeters. They give you another important information. The pebbles are sold in 20 kilogram gram bags and covers an area of approximately 0.36 meters squared, and he will need 12 blocks as shown in the sketch. So then the 3.2.1, calculate in meters square. Again, they are guiding you the total area of 12 concrete blocks. So they want the area of 12 of these concrete blocks. So we are first going to work out the area of one of the blocks. So 3.2.1, area of one block. So we have that is 50 centimeters times 50 centimeters, which is 2,500 centimeters squared. They ask that we need to convert this to meters squared. So if we are going to do the conversion, where are we? We are there. Where do we want to go? We want to go to meters. We have a slight difference now because we have 2,500 centimeters squared. So we are converting in area. So each jump will now be 100. In the previous question, where I showed you how to do conversions, in the previous one, we converted only in length. That is why each jump was only 10. Now we are converting this in area. That's why each jump is now 100. The answer is 0.25 meters squared. You could, grade 12s, you could do the conversion. You could start off by 50 centimeters times 50 centimeters. You could read the hint, see that they want the answer in meters squared, and you could go immediately and do the conversion because you've already done it in the previous question. Convert it to meters, and then we get exactly the same answer. However, grade 12s you feel comfortable with, that's the way you do it. That was question 3.2.1. That was to work out the area. Oh, sorry, I didn't finish that question. That was the area of one block. So the area of 12 blocks, we will then take the answer of one block, 0.25 meters squared, and multiply that by 12, and then we get that it's 3 meters squared for all 12 blocks. So that was then question 3.2.1. Then we're going to move along to question 3.2.3. Calculate the area of the walkway that needs to be covered with pebbles. So let's have a look at the diagram again. So that's the concrete blocks. We have that. They want to know what is the area that will be covered with pebbles. So what do we need to do? We need to take the area of the walkway, the length times the breadth, We need to get an answer and then deduct the area that the concrete blocks will take up. Because if we cut them out, then we will be left with the area that needs to be covered with the pebbles. So we are going to start with, to work out 3.2.3, the area of the walkway. So that will be the total area of everything. So that will be length times breadth, which will be 4.05 meters multiplied by 1.45 meters. And then the answer is 5.8725 meters squared. I'm not going to round this yet because it's not the end of the question. Let's just do rounding at final answers. So then the question said, this is now the whole walkway, the area of the whole walkway. Calculate the area that needs to be covered with the pebbles. So then we are going to say, take this area, and we are going to, in the previous question, we worked out the area of all 12 blocks. We're going to minus the 3 meters square, and then we get an answer of 2.8725 meters squared, and this one we will then round. Then the last question in 3.2.3, calculate the total number of bags of pebbles needed to cover an area of 5.7 meters square. All right, so they give us an area. They want to know the number of bags that we will need to cover 5.7 meters squared. So in our introduction, they said the pebbles are sold in 20 kilogram bags and covers an area of approximately 0.36 meters squared. So then we are going to take the 5.7 meters squared that was provided and divide it by 0.36, that's the coverage. This answer is 15.8. We can't buy 15.8 bags, so we'll round it to 16. Why are we rounding it up? We are rounding it up because if you buy 15 bags, there will be little space there somewhere in the walkway that won't have enough pebbles. So that's why we round it up to 16. All right, that was question 3. Now we're going to move along to question 4.1. This is a growth chart. A nurse from Port Allen Clinic conducts roadshows to demonstrate the use of growth charts to parents. She uses a weight for age chart for boys on an Annexure A, which shows, so this is Annexure A, this is a weight for age chart for boys. So the first question related to this, so just want to point out that we have weight in kilograms here and we have age, month and years. This indicates visits. Visit number 1 to the clinic, 2 and 3. Identify the age group represented on this chart. Okay, so it's from 6 months to 2 years. So it's either 6 months to 24 months or 6 months to 2 years. Give the boys weight at the first visit. All right, so this was the first visit, and then the boy's weight was 8 kilograms. Determine the boy's age in months during visit when he weighed a little less than 9 kilos. So a little less than 9 kilos, that was the second visit. So how old was he? There's 1 year and 1 month. So he was 1 year, 1 month, or 13 months. Then 4.1.4 said the boy's first visit was in May. Determine the month in which the third visit took place. So it's May, June, July, August, September, October, November, December, January, February. So the third visit was in February. Then we're going to move along to question 4.1.5. The question says, during the fourth visit, the boy's weight was 11.2 kilograms and his body mass index was calculated as 19.5 kilograms per meter squared. Calculate the boy's corresponding height in meters rounded off to 3 decimal places. So I'm going to rewrite body mass index, and I'm going to write weight, and it is in kilograms divided by the height of the person in meters squared. This is the formula for body mass index. What's very important is to know that weight is always in kilograms, height is always in meters. If they give you the weight of someone in grams, then you need to convert it to kilograms. If they give you the height of someone in centimeters, then you first need to convert it to meters. So it's the weight in kilogram of the person divided by the height of the person in meters, and the height must be squared. So what did they give us? They said during the boy weighed 11.2 kilograms, which is fantastic because it is 11.2 kilograms. That is what we need in the formula. And his body mass index was 19.5 kilograms per meter squared. So they gave us his body mass index. They want the height in meters. They want the height of the boy. That's what they want. So when you get a formula that's provided, write it down. Substitute into the formula what you have, what was provided, what was given. The weight in kilograms was given, the body mass index was given. So what is it that we need to do now? We need to go and work out the height of this boy. All right, so we need to solve that. So how do we go and how do we do that? We are going to change the subject of the formula. So we are going to change the subject because we want height. We are going to say 11.2 kilograms. We're going to divide it by 19.5 kilograms per meters squared. If you are going to do that with your calculator, then you are going to arrive at an answer of 0.574358. If you say 11.2 divided by 19.5, this equals to height squared. How do we get rid of something that's square? We get the square root. So if we get the square root, so if you take your calculator and you type in 0.574358, then we are going to get an answer of 0.758 meters. So the height of this baby or baby boy was, and they specifically instructed us to convert this or round it to 3 decimal places, so 0.758 meters. That is then the height of this baby boy. And that grade 12, that is all that we have time for this afternoon. So good luck with all your studies in all your other subjects, and remember, work out old question papers that will really help you for the upcoming exams.